Welcome to another Great Cow Basic tutorial. This is part 18 for the PIC18FxQ41 chip family. We're well into this set of tutorials. We're now looking today at assembly and alternative assemblers. And we're really building upon tutorial 17 where I introduced the complete tool chain. So let's get cracking. So I'm using a microchip, a low pin count demo board. I have definitely got some Curiosity Nano boards on their way, and I'll do another tutorial once they arrive to show the same capabilities. I've got one out in the lab here. Here it is, sitting out in the lab. It's just flashing away for us. Okay, all right, there we go. Look, and we'll be using that a little bit today, but it's not the main part. We're not looking at Great Cow Basic per se today. We're looking at how assemblers and linkers work. So what we're going to do, we're going to generate some code today. Let me just bring up my pen before I start. What we're going to do today is we're going to write some code, really simple code, in Great Cow Basic. It's going to generate some assembler for us, and I'm going to take that into MPLAB-X. So to show you that you can use Great Cow Basic to generate what's called a .s file, which is the assembler file, and that is the source for MPLAB-X using PIC-AS. And it's really simple, but it's something you might need to do if you're learning assembler. Why not use Great Cow Basic as a resource? If you want to see how the code works, how we've set it up, how it works at the detailed level. If you think there's a problem, walk that problem in your debugger, walk it through MPLAB-X as an issue. You shouldn't have many, to be quite frank. We're pretty confident about the quality. And there are other cases where you might actually want to change some of the functionality. And you can do that, and you can see how that works at the register level inside of MPLAB-X. Now remember, MPLAB-X has its constraints. It only works on 64-bit processors, but it does work, and I'm going to show you how that all works. So, going back to where we were yesterday, we're looking at what Great Cow Basic is. It's a compiler, it's open source, it does PIC, AVR, and LGTs, and now it supports these Q41 chip families, and it's cross-platform because it does all these different chip types, but it's also across many different operating systems like Windows, Mac OS, Linux, Pi, etc. So yesterday we saw how we take the source code, we write code, we consume libraries, and it gets processed into a lump. It goes to a code translator where it's put in a neutral language, and then we generate the assembly for a specific chip. Whatever you specified in your source, it will generate an assembly language file, and then it will link it and then put it out as a machine code. We saw that yesterday. But now, how do you use it with MPLAB-X? Well, I showed you this as well. We're going to do exactly the same in terms of source code and libraries. We're going to go through the code translator, through the assembler, and then we are going to tell it to go out to the assembly. It's going to generate an assembly language file. Then we're going to push it out to MPLAB PIC-AS. It will generate the hex for us, and then we're going to look at that. And we're going to do that from within Great Cow Basic to start with, just to show how it works, and then we're going to do it inside of MPLAB-X. Okay? So what we're going to do, we're going to do two things. We're going to review a simple LED program, and we're going to compile it using essentially in PIC-AS, and we're going to then push that code out to MPLAB, and then we're going to take the hex and program it. We're going to do that inside of the Great Cow Basic IDE, and then we're going to do a second step, which is we're going to create a project with 7 steps to get the code compiled. And then we're actually going to put it in the chip, and we're going to see it working. So we're going to create an MPLAB project using the Great Cow Basic .s file as the source, and we're going to create a project. And I'll show you how to do that. So let's get cracking and get started, and we'll see what's going to happen. So I've got a really simple program here. You can see it on the screen now. This is just one of the first demos we used. Standard bit of chip at the top. I've specified the chip. and option explicit, and I've said set port C.0 out and wait 1 second, and then set the LED off, or port C off, and then wait 1 second and set it on, and hence it's flashing. So I can program that, and it will then go through the supply. It will go through all the code, go through the linker, and put it out. But what it actually did, it called MPLAB on the way. Let me just generate a hex file by pressing the hex button, and we all see in here that it assembled the program and generated a specific file, and then it assembled that program inside of PIC-AS, and then it links it and assembles it correctly in PIC-AS. And PIC-AS is part of MPLAB. And with one command inside of your configuration, you can generate source code for PIC-AS. So let me just press Shift F7 to bring up the source code. And here is assembly. Let me just turn on the assembler. This is assembly code. It looks like assembly, smells like assembly, etc. Now, so that I've got my comments in here, I went through I have set up in my programmer preferences, I've said put in the show me the, you can see it on the screen, I want it show basic commands in the comments. I've done that so that we can see them in the source code. So I've generated, if you can see the title, a blink.s file from that source. So let's see how we can do exactly that in Great Car Basic. Okay, so if I come into here and I change this program up to 500 milliseconds, it's going to compile it. It's going to then link it out in PIC-AS, and then the programmer will then pick up the hex file that's been produced, and it will program it, and it will now flash at ½ a second. Lovely. There we go. And it says on my screen, which I will show you, the file 020_blinks has changed. Do you want to reload it? Yes, it's changed because I've recompiled it. So let's create a program in MPLAB and see it work. Okay. Now I've started MPLAB because it takes a few minutes for it to start up. Okay. So I'm just going to bring up a view of MPLAB like that. Hopefully you can see MPLAB on my screen. So I'm going to have MPLAB on the screen sometimes, and then sometimes I'm going to have to sort of do this quite nicely and quite cleverly. So here we go. MPLAB is there. There we go. MPLAB. So let me just create a project in MPLAB, will you? Okay, I'm going to create a project. I'm going to take 7 steps. File, new project, standalone project, and then say next. And you cannot see that on my desk, so I will do it all again. Cancel. File, new project, standalone project, next. Take a chip. I'm going to use the PIC18FxxQ41, and I'm going to select it there. Then select as your tool the simulator. Okay, it doesn't matter if you've got PIC-4, PIC-3, select the simulator for the time being. Next. Now we need to select a toolchain. Well, we're using PIC-AS, so just open that up and pick the latest version, which is 2.31 when I recorded this video. Press next. Then give it a project name. Well, I'm going to call this PIC18FxxQ41 PIC-AS _ PIC-AS, just because I'll give it a name. Now, what you need to do is what I'm going to do is in the editor, just take the directory from here. I'm just going to use that directory as my location for my project. Okay, all right. So I'm just going to paste that into there, and it's going to create a project of this name in that folder. And it's set as main project, so it will be the only project I've got. Great, there we go. We can see I have created a project in MPLAB. Okay, next, you've created the project. I just need you to add a source file. Source files here on the left, just right hand mouse button, add an existing item. And to go to the folder that you've got in your cut and paste bar, or the folder where the project lies, and just select the .s file. It's 020 underscore blink.s. There's lots of other files in there, look. But this is 020 blink.s. It's always capital S, okay? You'll know it's the right one. And select auto in here. Now I've got this documented. I don't want you worrying too much. So I've now added that source into here, and if you double click it, you can see it in the editor, okay? Right, there's a few more things we just need to do just to finish this off, okay? All right. So right hand mouse button, go into properties, select the simulator, and there's a simulator under conf default. Just set the frequency to whatever frequency you've set it to. It's 64. And I'm going to prove to you that you can program stuff in GCASM Basic as well. So in the IDE. So I'm just going to take a copy of my. Here we go. Look, I'll just take a copy of my programming command line from my tool. Now I want you to go in. So I've done the simulator, set the frequency. I want you then to go into the building, and select execute this line after build, and this is a programming line to get PIC-Kit command line or the PIC-Kit software to program. Press OK. We've created a project, added the source file, made a few changes in the properties just to set it all up, and now if I press production, build main project, it will build it and it will program it. And how can I prove that to you? It's because I can show you the lab, and the lab is flashing. I'll go back to MPLAB, and we're going to make a change in the program here. I'm going to make a change in here. That's 200. The delay is 244. I'll set that to 100, and we'll talk about this code in a minute. F11, reprogram it, and we will see that this LED will flash a lot faster. So we have a flashing LED, which is pretty good. And we've used the source code from GCASM Basic. How can I prove that to you? Well, I'm going to bring up the MPLAB, and I'm going to bring up here. There we go. And I'm going to change the code in here to 50 milliseconds. And when we go back and generate the code, I'm not going to program it. I'm just going to generate the hex file, generate the assembler. We will see that over in MPLABX, the source code has changed. Inside of MPLAB, you can do things like this: debug main program, and it will debug this program, and we can walk that code. Now it's running down the bottom. It's running at the bottom left-hand corner on my screen here. But I'm just going to stop it and just show you how to walk the code. Debug, discrete, launch debugger main program. And it brings you up a green line, and that's the first line in the GCASM Basic source program. Well, down here we've got the loop that we've just been playing with, and we got here it says port C0 equals 0, and there's another line, port C.0 equals 1. So let's put a break in there. I'm going to put a break in there and a break in there, and then I'm just going to run the code by pushing the run button in the IDE, and it will run the program down to here. And I can add inside of here a variable, and I can watch that port change as the code runs. If I press F7 in here, I can warp this code, and as it sets it on port C0 equals 1, we will see it change, and that change programmatically. Now it's going to branch back to sysloop 1, which is our do loop. Then it's got a delay, and then it says port C0 equals 0, and it will, if I press F7, it will toggle. You can now examine the complete code that's been generated by GreatCow Basic, but we're using, in this particular case of the Q41, we are using PIC-AS to generate the hex file. It works absolutely fine, and you can learn exactly how GreatCow Basic works. So I'm going to walk the code. The first vector is go to a particular jump. We always go to BAS program start, and then we initialize the chip. We set up the oscillator. That's the first set of commands. Down to here, we set it to 64 megahertz, depending on whatever you specified. We clear some 18S specific values that need to be cleared down. We then turn off the digital ports and turn on the ADs. Okay, we set things up correctly for you, and when it exits from here, all the ports are in a known state for you. It will return and then come into our program. Wait 1 second. Wait 50 milliseconds is what I'm actually running to. Toggle the LED. Wait 15 milliseconds. Toggle the LED and loop back. That is the complete program. But what I've shown you here is that you can easily integrate a GreatCow Basic, and then you can program it directly from the MPLAB IDE. So if I make a change in my code here, if I make a change here, I'm just going to show you the change again. If I make a change in GreatCow Basic, that is then represented, which I've just done in there. If I go back to my MPLAB, it has now changed it to 100 milliseconds. So I've got this direct link between the two linkers. So I'm using an external compiler, external linker to take the .s source that's been generated with GreatCow Basic through the compiler and linker of MPLAB, and then programming it. Because if I press F11, it will then generate the hex file and program it using PIC-Kit Plus. You could do the same with any program. It doesn't really matter. I just happen to have that one attached. Okay, so that's what I wanted to show you. Let's bring up the deck of slides. So I've shown you how you can use assembler and an alternative assembler. You don't have to use GreatCow Basic. If you don't want to use the MPLAB route, don't use it. You don't have to. You can just, because GreatCow Basic will do it on the 32-bit machine. You can only do what I've shown you now on a 64-bit machine. So GreatCow Basic will generate a hex file without using MPLAB on a 16-bit machine, so a 32-bit machine. So you're quite safe. Okay, so that's the end of today. Enjoy. The whole purpose was to show you how you can take code and take it out through an alternative assembler and linker, which I think I've done. Enjoy.